Now let's talk about photon energy. First of all, what are photons? I know you probably were confused from the previous slides when I had mentioned it over here, plenty of other places. Anywho, a photon is defined as a massless packet or a quantum of electromagnetic energy. Now, when it comes to the IB questions, you probably want to pay attention to key terms that will help you bump up the number of points that you're able to acquire from each question, specifically long answer questions. Now, there are fundamental particles that make up all forms of electromagnetic radiation. Once again, it mentions electromagnetic. So there's energy and radiation, pretty much the same thing. Definition of discrete packet of energy. Definition of discrete packet of energy. Each photon carries a specific amount of energy and transfers it all in one go. Now we did talk about specific amount of energy over here. Discrete energy, quantized energy, and specific magnitudes. And once again, exact energy when it came to the absorption spectra. However, here's a new point. It transfers all of this energy in one go. So it's discrete, not continuous, like waves are, because they transfer the energy continuously. Now, okay, these two terms may not be familiar to you. However, its abbreviation, excite, over here, stated in almost every single slide. Okay. I'm just trying to find it. Yeah, over here, excite themselves. So electrons absorb the exact energy, otherwise known as discrete energy, to excite themselves, as in to move from one energy level to another. And please don't get confused that, it only moves by one energy level. It can go from, let's say, this first energy level, the ground state, to, let's say, the third energy level, or second energy level, or even 5 energy levels, depending on how much discrete energy is provided to the electron. Okay, now let's start from where I left off. When an electron moves to a higher energy level, it absorbs a photon. However, for de-excitation, when electrons move back down to a lower energy level by emitting a photon. So that's the difference. Excitation is absorbing, de-excitation is emitting. Ionized atom. What is it? Oh no. Well, essentially it's an atom from which an electron is removed. Now, let's look at this diagram over here. All right. You have a ground state, as I've mentioned a couple of times in this video already. And this energy level 5, or n is equal to 5, as we talked about previously. Okay, so we got ground state and 5, where the energy level is minus 13.6 electron volts, and this is 0 electron volts. So let's say the electron's here. Okay, and in order for the electron to be removed, energy needs to be provided in order for it to exit this atom. And by this atom, I mean the diagram over here. Okay. Now going back to ionization, which is this entire section over here, it's a minimum energy required to remove an electron from ground state of an atom. So first, ionized atom is when the electron leaves, but how exactly is that done? Energy needs to be provided, and that energy provided to this electron is called ionization energy, which is the minimum amount. Okay, now here are a few formulas that you have to keep in mind when it comes to attempting any of the IB questions. However, I would recommend you, the audience, to memorize these formulas because it saves a whole lot of time when it comes to answering the questions and remembering everything. It essentially cuts back on the amount of time you spend on each and every single question and provides you time to actually process everything and figure out a way to apply these formulas rather than frantically searching for these formulas in the first place in the IB booklet, which may or may not help you end up at the right answer. So I'll highly suggest to memorize these formulas as well as these constants. Planck constant, speed of light, these are extremely important. I'm unsure of whether or not this is provided in the IB booklet, but you can go ahead and check it out and just send a message in the community letting us know whether or not it's available. Okay, now let's talk about difference in discrete energy levels. Remember how I was talking about the amount of energy that is required to excite an electron, otherwise known as discrete energy, right over here? Yeah. So I found the difference between the 13.6 and 5.8. Sorry, these are supposed to be negative. I forgot about that. I found the difference of 13.6 between 13.6 and 5.8 and received a value 7.8 electron volts. And now that is the amount of energy required to excite an electron. And that's the purpose of having this formula, difference in discrete energy levels. It's when electron transitions between energy levels. Now, as you can see in the note, photons with discrete wavelengths have discrete energies, which is equal to the difference between two energy levels. Now, discrete wavelengths, discrete energy levels, as you can see, it's a common trend. Yeah, you're gonna have to remember this word discrete. It's used everywhere, as well as continuous, but not that often. Now here's a formula for it. Change in energy is equal to E2, which is the energy of higher level, and its units is joules. E1 is the energy of the lower level, also measured in joules. And that is equal to HF, which is quite similar to this, but all I added was delta, which is the triangle sign, and E2 and minus E1. Delta E is essentially the change in energy levels, which is represented by E2 and E1 as stated over here. And yeah, that's pretty much it. Now the relationship between the energy of a photon and wavelength is that they're proportional to one another. So if the energy of a photon were to increase, so would the wavelength. Now it might be important for you to remember this relationship. Okay. Now it's crucial for you to remember every single relationship that is presented on any of these slides, as it could appear in the exams, specifically when it comes to graphs, because that's honestly a headache. So let's say y is energy, x is wavelength. Just making this up, so don't take this literally. So if this is a linear relationship, and if they asked you, okay, what exactly is the relationship between energy and the wavelength, then you just have to say, yeah, it's a positive relation. However, they won't ask you this directly. You might have to figure out the relationship between, let's say, frequency on the y-axis and some other variable on the x-axis, and then somehow have to connect the dots between those two and end up deriving this relationship. E is proportional to wavelength, as in lambda. This is called lambda. It's a way of representing this.